In this video, we are going to check what is diffraction, which is an optical phenomena. So let's see what are the objectives. We want to define diffraction and we want to analyze diffraction of light through single slit. Now this is a beautiful picture from our mother nature. You can see that there are water waves and the water waves are trying to come through a small opening between two rocks. So this small opening is actually acting like a slit. So this is the slit which we have got here, through which the water waves are trying to come out. And as they move through the slit, we can see that the water waves are spreading in these circular wavefronts. So this is an example of single slit diffraction from our mother nature. So let's define what is diffraction. Diffraction is the bending of the waves around the corners of an obstacle or through a gap. And they go into the region of geometrical shadow of the obstacle or aperture. So let's see what does that mean. We have got two diagrams here, one which shows an obstacle and one which shows a gap. So in the first diagram, we can see that there is an obstacle here. The water waves, as they reach the obstacle, they bend, and you can see that the nature of the wave fronts after crossing the obstacle is different. So the water waves are bending around the corners of an obstacle. Similarly, in the second diagram, we have got two situations. One is small gap and one is large gap. We can see that in both the cases, as the waves reach the gap, they bend. We can see that in both the cases they are bending. The difference is in the small gap, the bending is more, whereas for the large gap, the bending is less. So we can say that the diffraction decreases when the gap size increases. So smaller the gap, we'll have more diffraction. Let's look at something more interesting in diffraction. The wavelength, which is the distance between the wavefronts, does not change. So during diffraction, the wavelength would not change. And what is wavelength? Wavelength is the distance between the two wavefronts. So this distance is the wavelength, and we can see that it remains the same in the process of diffraction. So just to recap, what is wave and what is wave front? So let's see. In the first diagram, we can see that this arrow is showing you the direction of wave, whereas the perpendicular lines which you see, they are showing the wavefronts. So these are the wavefronts. Which is a collection of the crest or trough. Same way we can see here the wave. So let me use the same color for the wave. The wave direction is this, whereas the wave fronts are these lines which you see. So after crossing the gap, you can see that the wave fronts are becoming circular in shape. But the distance between the wavefront before and after remains the same. That's the significance of this second point, that the wavelength does not change in diffraction.